Hello, everyone. Good evening, good morning, good day, wherever you're joining us from. Thank you so much. You've made it this far and you've been through an amazing journey. We started off with basics of databases. You started off with understanding data ingestion, the pipeline, the whole pipeline, data analytics. We did BigQuery. We understood Cloud SQL, basics of Data Studio. We also looked at uh, leveraging data sets, public data sets that are directly available in BigQuery for you to use in your prototypes and your applications that you want to test. And you went further and did built applications with anti-gravity IDE, and we also use Gemini, Google AI Studio. And in today's session, we'll take all the learning that we have done on cloud so far to build multi-agent applications. And before we start the session, today's speaker I want to introduce really quickly. He's Stenel. Stenel's also a Googler. He is in data science. He's been in data science. He's been building solutions. He's a senior solution architect, and you would have seen him in some talks, and also I have mentioned him a couple of times in Code Vipassana sessions as well. And all our Code Vipassana leads are also there in the chat, some of them, and also a couple of other Googlers, Shruti, Sneha, and Tej are also there. Coming back to our speaker, Stenel will be walking you through building the multi-agent application. Feel free to keep your questions in the comment chat, and keep the questions related to today's session coming up. Anything else related to previous sessions or overall the initiative's objective overall, please refrain from asking here so that it's not distracting for everyone else who's asking today questions related to today's sessions. Use the Discord channel. You would have all received an email right before the session, a few hours before the session start today. And even previously, yesterday, you would have received an email from me with the email from RSVP, Patchamomma initiative, with the most recent link, skills lab link that you can use to redeem your 9 credits for doing the lab today. So today's lab, watch and listen and learn while the session is going on. Do not try to actively do the step one by one, because if because everyone's trying it at the same time, there are some regions and some services that are accessed from the same region. And if there are more than at peak, there'll be more than 1,000 people joining us, or we don't know, 100 people or 500 people, sorry, or multiple folks trying to join in at the same time, and the lab may not be performing as well as we would like for it to be, because these are trial credits, labs that use trial instances. So the best thing for you to do is observe completely, understand everything that's going on, take the concepts from that and try the lab afterwards at your own time, at your own bandwidth, and nobody else is sharing that all the bandwidth with you at the same time. When I'm talking about bandwidth, I'm talking about sharing the same skill lab. And again, a lot of questions on the Discord channel about status of completion for the previous labs. Don't worry about it. The whole point is for you to understand what's going on with the what's covered in the season, in the session, in the series, and what's going on in the series overall. So for you to connect the dots and to learn, starting from data to building the application to understanding how to put analytics together, and then to today's session where you'll learn how to build multi-agent application, and the last session in a couple of days, you'll also, like on Wednesday, you'll also learn about how to host, what will be your serverless runtime and all that. So putting all the stringing the pieces together, how to get your idea to application end to end. That's the learning journey we care about. If you're not able to, if some step is not confirming your or validating your completion, that's fine. It's not the validation email that we'll ask. There will be a pop quiz, like I said, at the end of 5 sessions, and that quiz is designed to understand your knowledge. It's not about completion certificate, so don't worry about it. The pop quiz will be covering some of the things from all the 5 sessions that we have 5 labs we have covered in the series. You will get it only after all the 5 sessions are done, so everyone will have the fair opportunity to jump on it and respond. So don't worry about that at all. And if you have not received your email in your inbox, feel free to look at spam. Sometimes accidentally, if there's a possibility, because continuous emails about some reminders are being sent. So just for being on the safe side, also check in your spam or other crash emails in case you accidentally pushed it there. So make sure you check everywhere. If not, you'll also get a follow-up email right after, not right after, but at least tomorrow morning, first thing you'll receive the email along with the video on demand as well, along with the credits, 9 credits link, which was also shared 2 days ago or yesterday for that matter. So you have it in your inbox somewhere. If it's not in the inbox, just look at your spam. So that's something I wanted to lead with. And one last thing, like I already said, more updates about the collaboration for the finale and what's going to happen. Everything is up there on RSVP site. It was also there on the email that was sent to you all yesterday. And what you need to build, how complex should it be, and all those things, more details will be sent in sequence. Let's go in order. Don't jump into that. I'm not saying you shouldn't think. Keep thinking. Keep thinking about the ideas that you want to work on. Make it groundbreaking. Think of something. I'll give more details. We'll need a dedicated email for that, so that keep checking your emails and make sure you're watching, you're following the emails. There are some LinkedIn emails from my LinkedIn updates from my profile as well. So keep looking at that as well. But your email, your inbox or spam will contain, um, if you're an approved Pachamama participant, it will contain the details about what is the next step. So after 5 sessions, you'll get a pop quiz, and after that, you will get an email about the instructions on what to build, or not what to build, but what are the criteria, how to get started, and all that. All right, excuse me. All right. So we have exactly an hour from now to complete the session and then open it up for a few questions. I look at the chat at that time too. So I want to give it over to Stenel. Stenel, over to you. I hope you all have the links from the email, the lab links from the email. Let me share once again. I'll share my screen. Take the lab from your email and make sure that you're looking at the steps as Stenel walks you through it.
Hi, B. Thank you. Thank you so much. Can you hear me? Thumbs up. Yes. Awesome. All right. Cool. So, thank you, everyone. Good evening. Good morning. So, today we will primarily do the session on multi-agent system. So, talking about agents is easy, right? But building agents can be sometimes a little bit tricky. So what we will do is that we will go through this lab as a collaborative session, and we will try to cover 6 agents. Okay, so you have the agent skill lab link available to you. So those you have done or those you want to participate, please. But I encourage you to learn from this session and do the sessions later so that we all does not go into the system altogether. Let me share my screen. All right. So I have already started. So if you are starting for the first time, you will get a start button over here. You can click on that and you will get the lab setup wizard. But before before we jump, right, what are the things that we want to build today? So we will be primarily building our agent for different areas. So we are, like I mentioned, we will be using ADK. So ADK is the agent development kit which Google provides to empower you to build more advanced agentic systems. What are the different systems that we have the capability? We will start from a simple, very direct, straightforward scenario, and then we will go in depth as well. Those who are doing labs or the skills for the first time, like I mentioned, you can click on the start button and you can click on the labs. So once you have the lab set up, you will get a student credentials. Either you can open the console and put the username, but the easiest option I suggest is that right click on it and click on the incognito, open it on the incognito window, which opens the GCP, the Google console directly, which makes it easy for you to open it in a system where you can directly log in without providing the credentials as an external system. So once you are in the GCP, so those who are for the first time, you can see that you will need to agree to the terms of service. I can click on agree and continue. Once and this is the Google dashboard. Most of you are already familiar with the dashboard, but for those who have not, This is the GCP Google Cloud Platform. And in here in the left side, you can see all the different categories of services which are available. I will minimize that for now, but you can always come back and click on here and get it. So on the top left, you will see the project that you are inside. So you can click on it and you can see your project and project ID as well. So what we would do is that we need a mechanism to invoke our code, and we need a working environment. In order to get a working environment, I would like to use something called Cloud Shell. So how do I get Cloud Shell? Cloud Shell, you can see that there is a, on the right corner, you can see a button like this. So this is an activate of a Cloud Shell system. So what I will do is that I will come here, I will click on the Cloud Shell. So this will activate, which will give me a pop-up window. So this is a slider window. So you can use that to enable the Cloud Shell. I would say, okay, continue. It will provision my Cloud Shell machine, and it will ask for authorization. Wait for a moment. It will authorize into the new account which is there, and it will connect me to the system. Awesome. So those who are doing, you have already, those who have already done, you are familiar with the terminal environment. So I have got my Cloud Shell terminal environment right now with me. What I will do is that I will keep it, I will move it aside, and I will come back to my lab. Okay, so what are the first steps? Like I mentioned, we started our lab, we opened our lab environment in a incognito window, and then I have opened my system. Now let's talk about our multi-agent system, right? So we have different ways to create a multi-agent systems, and like I mentioned, ADK makes it more easy because creating agents is talking is simple, but creating when it comes to the production level system, it is a little bit more hard because it involves a lot of functionalities. Now, what are the things as a developer we want in an agent system? We want a easier mechanism to design. We don't want a very complex system. We want specific agents for the specific jobs and skills. We want the specialization of the functions, which will make our more reliable performance. We want it to be an organized, right? We want it in organized structured format. So I want it in organized, I want it to be readable, and I want to maintain it for a more time frame, and I want it to modularity. I don't want everything to be given in a single format. By default, all the agents in ADK will be having a hierarchical agent tree structure. So what does that mean? This means that I always will start from a root agent. So I will have a single point of entry. So those who are familiar with programming languages, right? We have a main function which will be used to invoke other executions and commands and other functions. So we want to have a entry point. So root agent is our entry point. So let's say I have my root agent in here. This root agent, I can have more subagents. So I can have two subagents here. And these subagents can also have different subagents. So it goes like a tree structure, and that's what makes it as a hierarchical system. Now, how does it work? We agent ADK involves in, or gets inspiration from the real world itself. Like we want our system to be very intuitive so that we can develop in a very controlled manner, and it should be very intuitive in a nature that it should make sense to whoever is using the agent development kit. We here have a parent. So the parent will act, the root will act as the parent, and we will have more other agents, sub-agents, which we can identify as in our environment. Now coming back to our lab, if you click on here, you have the terminal. Then I have a mechanism. I have an open editor as well. So if I want an editor view, I can get it. But what I need to do is that I need to get my code. So initial boilerplate code, you don't have to worry about, because in the lab itself provide you a set of code which is available. So you can come here. you can see that there is a gcloud command. So this, what it does is that our initial code is in is in a GCS bucket, which is our storage bucket, and we can copy that code from our storage bucket into my local Cloud Shell environment using my gcloud command. So what I will do is that I will copy my gcloud command, which is gcloud storage copy command. I will come to my terminal and I will paste it over here. Once I have this, I will press enter, which will get me all the GCS bucket. So it is done copying. And now what I will do is that I will click on my open editor. So this will, what it will do is that it will give me an editor view. This has given me an editor view in which I can see that all my files have been copied. So you will see a folder called ADK multi-agent system, which has two folders, parent and subagents and workflow. These are the demos that we will be working with today. Next, what I want to do is that I want to get my path so that I can get my environment variable set. So I need to export my path to have my local path exposed, and I want to install my Google ADK. So in particularly, I'm using 1.3 version over here, and I want to install all my dependencies into my system. So what I will do is that I will copy this. I will come back to my system. I will click on my open terminal again, which will bring my terminal. I will paste it over here and I will wait. So what it does is that it will go first, it will export the path. It will go into the registry and it will use my Python 3 version, and it will go to the registry and download all the dependencies. So in here, as you can see that my system is downloading all the necessary dependency for the ADK. So this is the ADK installation steps that we are supposed to follow. So once we have the ADK installed, then we can explore more into the system. So what are the system that we are going to build? Let's go back to the instructions, right? So task one, installing the ADK, setting up the environment. Pretty easy. We don't have to worry about too much of things. We just want to make sure that we got the lab, we have the Cloud Shell enabled, we have access to the terminal, we have access to the VS Code, and we have successfully copied our code and installed ADK. So you can see that my ADK is progressing. It will take a few minutes, but meanwhile, I can go ahead. So once we have done the ADK, installation of the ADK, what I need to do is that, okay, I will go and find my root agent. Like I mentioned, we already got a set of code installed available here. Okay, now my ADK installation is done. I will go into my editor. I will go into my parent and subagents, and I'll go to my agents. In here, it has opened the code. You can see that fairly it is a very simple set of codes. So what I need to do is that I need to go to my root agent. So I will go down because this needs my agent to be start. I need to start from my root agent. So that is my application is definition. So in here, you can see that I have an application which is using application root agent, and this will be my starting point. So I need to go to my root agent. You can see that, okay, I have to create an agent. I need to provide a name. So initially we are going to build a steering agent, and the purpose, what is the functionality of the steering agent? So we need to provide an instruction for the steering agent. I'm saying, okay, ask the user if they know where they would like to travel or if they need help in deciding. So this is a pretty straightforward, but it is missing some other things because I have not given any of the other details. So let's start from the beginning. I need, before I start using my system, I need to make sure that my Cloud Shell environment is using the correct credentials so that I can invoke my Gemini APIs. Instead of Gemini API key, I'm using a different authentication mechanism, which is my Vertex AI. By setting my Google Gen AI use Vertex AI as true, I'm making sure that I don't want to expose any API key. I can directly use my Vertex AI endpoints to use that. So let's create a .env file, which will have my environment variables. So I will copy this. I will come back here. I will open my terminal. So you can see that I have already done my ADK installation. I will just clear it. I will paste this and I will run it. So you can clearly see that, okay, I have created a .env file in system. If you open the editor and if you look at it, oh no, I'm not seeing it. Why? You can see those things by click on view and toggle hidden files. If you click on toggle hidden files or the dot files, like in Linux environment, right? If you want to have an file hidden, you can just add a dot on the top or on the beginning, so that will be considered as a hidden file. So all my .env files are also considered as hidden files by default. So if I expand on my parent and subagents, now you can see my .env file. If I click on it, I can see that, okay, I have set my vertex AI as true. I have set my cloud project, whatever the project I have got, which is the environment variable. I have also mentioned my location. I want the global endpoint, and I'm going to use Gemini 3.5 flash models as well. Now, since I have two agents, I want to use the same environment. So let's copy my parents.env into my workflows.env as well. So I will use the same environment variables in both areas. So I will copy this. I will come to my terminal and I will execute this. So I have my both my workflow agent and my parent and sub agent both having the same environment file. Now we will come back to our steering. So our steering, our right, the agent.py, right? We have our root agent, which is a steering agent. Even though we have other agents defined, I have not done a connectivity between these agents. How do I do? So what are the different agents? Let's start from the top. So I have imported all my other details. I have loaded my environment variables, which we just provided now. Now I need to provide a set of subagents. So what are the subagents I can define? So I have defined two subagents in here. So I have an attraction plan agent. So this agent I have just mentioned provide the user for an option of attractions to visit. Nothing else, right? I just provide a name to my model, my model which I most model I need to use. We have provided that in the .env file. I have given an instruction on how the model should behave, and I have given a description as well. So I have given first mod sub agent, and I have the second sub agent, which is my travel brainstormer. In here, my system instruction is my instruction is provide a few suggestions of popular countries for travelers, help them identify. So how do I connect these into my root agent? In order to do that, I need a one-liner. What is one-liner? I need to define, I have already defined my agents. I need to attach it. So I can say that my root agent has some subagents, travel brainstormer, and attraction planner. You must notice that I am only giving this information in my root agent. I don't have to make any other modifications in for my travel, my subagents, which is the attraction planner or the travel brainstormer. So once I've done that, I will save that and I want to execute it. So now we have the agents.py file. How do I execute it? I will come back to my terminal. I will clear this out and I will go and execute it. So ADK provides a two different mechanism in which I can execute my agents. One is that ADK run command. So you can see that I have an ADK run with my agent's name. So I need to go to my directory in which it will invoke it, and then I need to run the ADK run command on it. So let me copy that. I'll paste it. It should give me a terminal-based agent system. So you can see that now I have started my agent and it is asking. So it is waiting for my response. I'll just say hello and make sure my. So now you can see that the specific agent that's specific. So this makes sure I have got the response from the steering agent. Steering agent, the name that we provided for the root agent. So I can confirm this root agent is asking me, hey, welcome to our travel adventure. Do I know where should I go already? As of now, I need some help. I would say, okay, I could use some help. I would say, okay, please do help me on this. So what we are expecting is that since we have two subagents and our system is having a travel brainstormer, you can see that the steering agent that we had earlier, which was the root agent, has also already escalated into the travel brainstormer agent and give, okay, these are the popular travel places, Italy, Japan, and a lot. So I can see that my steering agent instruction worked. It handed over the instruction to the travel brainstormer and it has got my request and given me a set of options to work on. Now I can go in detail to my travel brainstormer and do, but let's for now we will just exit in here because we want to do more items, right? So what are the different things? So if you go back to the agent again, I have only provided as the user if they want to travel or not. So I have not given any other details to my instruction for my root agent, but I can be a little bit more. So ambiguity can cause a lot of issues. So it is much easier for the agent to understand the intent. So I can say, okay, instead of doing that, I can just add the following instruction into my system. So I can come and say, okay, if my user is asking for help in deciding, you can use the travel brainstorm agent. And or if they already know the details, you can use the attraction plan. This helps the when you build the agent, this helps the agent to have, even though they have context on what are the available sub agents, if you have more than one sub agent and you want to have specific instruction given when to invoke, how to use the sub agents, you can provide those in details in the instructions itself. So now we will go again. We will go back to the terminal and we will run the ADK run again. So I have done the updates. I have saved the file and I'm doing the ADK run. This time I would say hello. So I'm expecting my steering agent to respond back. Yes, I can see my steering agent is responding back. I will say, okay, I want to go to Japan. I have never been, but I would want to go to Japan itself. So what is the expectation? Now, since it is not a brainstorming, my agent should know this is a sub-agent of attraction planner. You can see that my attraction planner sub-agent has been kicked and it has given me a lot of options as well. Now, I can say, okay, this sub-agents, but I can also come back. Oh no, I don't want to visit it. Okay, let me, I don't, I don't know where should I go. I would simply suggest, okay, I don't know what to do. Can you suggest me something? So this time you can see that it wasn't. So we started from our steering, then we moved to attraction planner. Now you can see that it's again kicked me off to it again kicked me off to my travel brainstormer. So how did it possible? So this got possible because we have a mechanism of transfer, peer-to-peer transfer. Even though my current state involved in having my attraction planner, I was able to switch to my travel brainstormer because I did not explicitly mention peer-to-peer is not allowed. So by default, ADK allows transfers to peer, but if you want a different mechanism, you can have a variable called disallow transfers to peers and set to true. So this will make sure that you won't have. So once you complete all the steps in the lab, if you click on check my progress, you should ideally get a tick. Okay, well done. So I have got a score of 25 out of 100. Awesome. Now, since we have already made a multi-agent, because I had a root agent, I had two traveler agent, I was able to hand off from my root to my brainstorm, brainstorm to traveler, traveler to brainstorm and all. We want to do a little bit more adventurous, right? So how we will do? using till now, we were in a chat session or a conversation. ADK by default have something called sessions. So sessions is the chat history, or like when we have a long chat, right? For example, when you are in Gemini or you want to talk a long session and you want to switch to a different conversation, you will click on new chat. Similar to that, each conversation in ADK is contained within something called a session. So this will have primarily two details. So session will have all the conversation history which we have been talking about. So conversation history will be used for the generation of the response. And it also has something called a session state. So session state is a key value pair dictionary which can be very useful when you want to store some important data, or even if you want to store the complete output of a response as well. So how do we can maintain, how do we can use that into our system? So in order to access the session state, what we are going to do is that we are going to create a tool and expose that tool to one of our agent so that we can use it. So I will go back to my lab. I will click on open editor. You can see, okay, I have still my steering route agent. I have my travel and my system. In the top, so around line number 27, you can see there's this area for tools. So I need to define the tools before I invoke them. Okay, cool. So I will copy the code, which is my tool definition. I will come back to my code and I will paste it and save. So in here, I have defined a function. My function is called save attraction to state. Okay, what are my parameters? I'm saying, okay, I have a tool context, okay, and I have an attraction. So in tool context, you can see that this is the type of tool context which is coming from the ADK tools context itself. So in this, I have my doc string which explains the functionality of the tool, because the system, the agent will see the tool definition and my uh, doc string as information to agent. I need a mechanism to return and read the state. So my tool context has a variable called state, and I'm saying I want to get a key called attraction. So if it is empty, I just want to give an empty list. So the first time when we have in a non-existent, it need to be returning an empty list. So I will use my tool context state and get the key for attractions. And once I have that, I want to update the existing state. So I got the new attraction list from my arguments. I can say, okay, I want to append to my existing attraction the new attraction. And once I have done the procedure, I just say, okay, success. So we have defined the tool, which does not mean we have made use of anything. So how do we go that? So in here, if you come back, we are going to use that into the attraction planner. So in the attraction planner, we want to define the tools and we want to use the function. This is the function that we just defined. So I want to use the save attraction to state as a tool and expose that into attraction planner. I will copy this. I will come down and I will come down to my attraction planner. And in here, so I need a place to save this. So I have given into the attraction plan agent, I have given the variable parameter tools, and I have linked that to my function as well. So this tool I have created, I'm exposing to the attraction planner agent. So where are we? We are in the task 3. We have defined a tool. We have exposed that tool. But just exposing the tool might not be given explicit context to the agent. So like I mentioned earlier, it is better to have more details exposed in the instruction in the system. So what should I do? I have a more detailed system instruction. I will copy that. I will add that into my attraction planner. So I would say, okay, when the user wants to when the user replies, right, I want to use the attraction state and use it. As you can see that I'm using a variable attractions with a question mark over here. So what is this? In ADK, this is called key formatting. So key templating. So key templating allows the user to attach the keywords from the dictionary state dictionary and use that appended into the system instruction directly. So you might say, what is the question mark? So this question mark makes it optional. So the initial state, right? My attractions can be an empty state. It might not be holding any value. So I don't want the system to throw me an error. I can say, okay, this is an optional value, but if I have some attraction, you need to insert that over here. So I have created my tools over here. I have created my attachment of the tool into the agent. I have mentioned when to use the tool in my instruction, and now it's time to invoke. So earlier we used ADK run command. In here, I will use the next version, which is the ADK web. So ADK Web allows us to you have a UI, a web-based interface, so to interact with the agent itself. So ADK Web. So earlier we used ADK Run. In here, since I am executing from my Cloud Shell environment, I want to allow my request to go through all the origins coming into the system. So I will say allow origins with all my Cloud Shell uh, input requests. So I'll copy this. I'll come back to my lab. I will click on Open Terminal on the top, which will give back my terminal window. I will say ADK Web and I will execute. So this way I can start my ADK Web. And once you start the application, by default, it will go into port 8000. You can click on here to open it, or if you're familiar with the web interface, you can click on the uh, web preview and change port and port 8000 itself. So I have clicked on here, which opened a new tab for me, which is the ADK web UI. So in here, you can see this is a very simple UI. In the left hand side, you can see there's a drop down for an agent selection. Since I started from my root directory, I have two agents available. We are working with parent and sub agents. I selected my parent and sub agent. After clicking, it gave me a session. So it automatically created a session for me. You can see I have an input box. I can have attachments. I can have audio, video, and text box as well. I have a lot of other information currently which is empty. We will go into this in a bit. So now I want to say, okay, now I will start my conversation with a simple hello. I will come back here. I will say hello. Now my request, you can see it went to the system. It was loading and my stream. So if you hover on the icon, you can see that it is still. So whatever we saw earlier in the system, we can still see the similar information in here as well. I can see that my steering agent has responded me, hello, welcome to my travel adventure. Okay, good. What should I do next? I want to go to Egypt. So I will just say, okay, I want to give an prompt like I would like to travel to Egypt. So this, you can see my current agent is steering agent. It did a steering agent. It called a transfer to agent. So now it is a little bit more explicit to see what's happening over here. You can see that I have my transfer to agent got invoked. And in here, I can also see what is the argument. I can see, okay, which agent, our agent name is attraction planner because I'm not brainstorming. I can see the attraction planner is the info. It has done okay. It has executed that successfully, and I got a response as well. So if I hover on this, I can see that okay, my attraction planner system has given me a response, and I can see all the details in here. So I will say out of this, I want to go to Phoenix. I will say this thing, and this I'm giving back to my attraction plan. So on the left hand side you can see all my invocations. So I started from my hello, and then I started go to Egypt. So I will select one of it. You can see that this is the trace of the system. I will go there. I have the invocation. this invocation invoked the agent, and then it called the LLM, and then it created the generated the system. So here now I have invoked my system, and in this I had the attraction planner. We have created a tool which is called save attraction to state, and attached that tool into the attraction planner itself. So we have got the attraction planner state invoked, and if I click on that, you can see a diagram. So here it is a much more easy to visualize system. I have the route agent, I have the business travel, I have a planner, and I have a tool which is called attraction to state. You can see, and I have created a success state. So if I click on this and click on this, you can see my there is a state which has the key of attractions, and I want to go to my location as well. All right. So I can also say what are the other options. I can say I want to go to Grand Egyptian Museum. I'll say at museum. It will invoke that. It has updated my state, and if you come back, I can see I have multiple states available in the system. So what will I do? I can also write my system instruction I have already given. I have If I have a list of systems, I want this system coming up, right? I have the ADK. I will say what is on my list. I have already got the list, because how did I get this information? Because I was able to save this data information into my state file. So we are at the end of task 3, which allows me to check for my progress. And yes, the system says I have completed my task 3 successfully as well. Cool. Now we are halfway into the system. So far, we have developed one-on-one systems, right? We have developed the agents which can do one task, and it takes a turn and come back to us and give us options. But what if we want to define a little bit more elaborated system? What if we want to build a more autonomous agents? This is where we have the power of workflows. It's a workflows in agent. So we can have specialized agent to do a little bit more complicated tasks. So I can have a sequential agent. This will have a series of agents as input, and it will allow us to invoke next agent in a series of fashion without you requiring a user to provide an input. Then I have a different agent called loop agent. So this agent allows to run a series of agents in a loop until the loop is broken or the maximum iterations are met. Then I have a parallel agent. This will allows us to run multiple agents in parallel individual contexts without having an overlap in the system. So what are we going to build? We are going to build a big production line. So in our system, we will have a big system which runs a sequence of loop agent followed by a parallel agent. Inside the loop agent, I will have a big researcher agent which will write a screenplay using a tool called into the Wikipedia. Then the critic will give me feedback, and it will run the loop until the critic says, okay, all good, which will pass into my parallel agent, which has consists of two agents, a casting agent and a box office research agent. Once the system, both agents are done, we will see that. Now, I know this can be a little bit intimidating and complex to build from a single shot. So what we will do is that we will go in a simple sequence of manner. So in the task 4, we will try to create a sequential agent. So like I mentioned, in sequential agent, we have only simple tasks. So we have a research agent, we have a screenwriter agent, and we have a file writer. What we want to do is that we want to run the system with an initial prompt, and it should kickstart my sequential agent, and the researcher should do the work using the Wikipedia tool. Then it should hand over to my screenwriter agent automatically without me doing anything or without any human intervention, and write into the file. So this is our input in the task 4. Okay, let's back to our system. So I will open. So in here, I will come back into my Explorer on the left hand side. Let me disable my hidden file so that it is much easy to work with. I have the next system or workflow agents. In here, workflow agent, I only have a single file called agent.py. I will open it. Again, I have a very simple agentic system. I will come back from the bottom. I have my root agent, which is my greeter. And this has a tool append to state, which we similar to what we did earlier, which also has a sub agent, which is like a film concept team. So my app is defined and it is pointing to the root agent. The root agent is a filling concept team. So I will go in here. I will go into the film agent. Now you can see earlier we used to call just agent, right? Now this is a sequential agent. So what is the sequential agent? So I have given the name, I have given the description as well. So what are the agents that? So it is an ordered list. So in here I have a researcher agent, I have a screenwriter agent, I have a file writer agent. So we will go in depth. Before that, what I will do is that we will start. So again, I will come back to my terminal. If you already have the system running, you can press Control C to exit it. I will clear it again, and in here I will run the command again. So the only thing that you notice a little bit more system is that I have added a reload hyphen reload agent so that I don't have to every time when I make code changes. So especially when you're developing your agents, you don't want to restart your agent every time. You can just say reload agents. So whenever I make code changes, it will automatically restart on behalf of me. So I don't have to worry about my agent up to date or not. Okay, so we have our system running. I will open it in my port 8000 itself. If you already have other agent running, it will be in a different port. But if you have killed it, it will be port 8000 itself. So I have my agent. I have my workflows agent. Okay. Now I would say I would start again with a hello. This would give me a response back. Let's see. We should have a response from the creator. Yes, the agent is ready to help me with my next movie. Okay. Now I can select a famous person. Okay. Let's say I want to have a story based on this person. And what the agent should do is that since we defined a sequential, so it has called a Wikipedia, it has appended to the state, it has transferred to the film concept agent, and it has. So the Wikipedia agent, if you get an unexpected value or error, what you need to do is that you need to come to the system and you need to come to the top. And what you need to do is that you need to create you need to import the Wikipedia and you need to set a user agent because that would comply with the Wikipedia policy. So I would come and here and import the Wikipedia and set the user. So where did we use the Wikipedia agent, right? So here you can see that in my list of systems, I have my sub agent researcher as my first agent. So if I come back, I can see, okay, researcher is an agent. I'm using the same model which I got from the environment variable. In here, I'm saying, okay, define my prompt, define my plot line, and if I have any feedback and my instructions. And in here, I have a list of tools. So we have exposed a Wikipedia query run tool, which we imported from LangChain tool. And we also have the append to state. So I will come back here. I will create a new session, expand this a little bit more. I'll create a new session. I will say hello. It will give me a greeting back. I will take Ada Lovelace this time. Okay, I need a movie based on Ada Lovelace. Then I will wait for the system. Okay, just continue. It should automatically do the next step. Yes, it is appending. So you can see that it has done. did the transfer from film agent. It has provided the details into the response state. So you can see in the state, okay, I have the research state available in here. You can come back in here and you can also see my system. So here in the detailed view, I have my creator starting. It kicked off with a researcher agent. It used a Wikipedia tool and it went to my screenwriter. It will go into the file writer, but the screenwriter and the researcher is using the append to state as a common functionality to transfer the data, and I got the system. Okay, cool. Now I have done the research. I have done, and everything is ready. It has returned to my file. So you can see that each stage, it has gone to the file state, it went to the right file, and it is completed. Now, if I go back, I can see there is a movie pictures folder created, and I can see that poetic science.txt. Cool. I have my first. So what I have done, to reiterate, I have created my greeting agent. The greeting agent transferred my first request to my film concept team. And the team consists of three agents: researcher, screenwriter, and file writer, which ran in sequence of one to other and created the feed awesome movie line for the first system. Cool. Now we have seen all this. Let me go back and check my progress if I have completed. Yes, awesome. Now, this is just one time, right? My researcher did some work, it gave to my screenwriter, and it created my output. But I want a little bit more autonomous system. This is why I want this to run in multiple times. I want to run this in a loop. So in here, I will say, okay, do the research, do the screenwriter, and then have it passed into a critic instead of my file writer. Let the critic do the actual work and do the get me some feedback and give the feedback to my researcher back. So it will initiate from the beginning again without waiting for the user, and it will run in the loop until the critic says, okay, this is good, and exit for the loop or the number of iterations that we specify. So in order to do that, we need to change our sequence writer, right? We have the sequence writer and the first researcher into a loop agent. What we will do is that, okay, so we need a mechanism to exit out of the loop, right? Because when the critic says, okay, this is good and we need to exit, we need to exit right in the loop. So that is a tool I will copy. I will come to the top. I can see that, okay, I already have my Gemini info. I will come here and I will import my exit loop. Now I need to add a critic. So we have not defined my critic. So in critic is I have a new agent. It has the instruction how to decide when my research is good or not. If my plot line is good, then you can use that exit loop tool to exit out of it. Otherwise, you can provide my plot line and research. So you can see I have given two loops. So let me copy the code for the critic. I will come here. After the tool, I have the agents. I will add my new agent. So I have my critic in here. Now I have my writer. So I have my writer's room. So we will create a new loop agent. So this loop agent will be having the researcher, screenwriter, and critic. So this will do a maximum iteration of 5 times. So why we need a maximum iteration? We can decide that you can until my critic can say, okay, this is good. But in most cases, it is not an advice system. What we will do that we will make sure that, okay, even if the critic is not handling properly, we want to limit the iteration so that we are in control of the system. So let's copy this, okay, and we will come back. We want to do the critique, before our film concept. We will say, okay, I have my film concept, writer's room. Okay, I have the writer's room agent, which is the loop agent of the researcher, critic, and this thing. So it was earlier my film concept team. Now I need to update it, right? My update is that I need my writer's room to do in a loop and then call the file. So I will update my uh, film concept team to have, instead of all these three, I will say do the writer's room in a loop. After the writer's room done, they then only you come to the file writer. Okay, so now we can see that I have designed a system. Let's go back in here. I know my agents are reloaded. I will come back and create. I will say hello. I will start with a hello. Then I will give my so here instead of a person, I will say a different value. I would say I need an industrial designer who made products from for the masses. So this is my plot line. So it should ideally get me, okay. So it should ideally get me a plot line. It transferred the system to system. So it is going in a loop. It will come back to Wikipedia again. So continue. I don't need to. It is done the Wikipedia. It is going back and again. It is going in a loop. So each time you can see that what is the query that it is making to the system. You can see it is invoking multiple times. Okay, now everything has been done. You can see. We will wait for it. So meanwhile, we will come to the state. You can see that, okay, in my state, I have a lot of different information. Okay, I have picked a name, I have got the information, I have details. So let me also open my state file as well. So now how does my state look like? I have the starting of a greeter, then I have a writer's room. So the writer's room, and in here I have a file writer and the system. I have a film concept team in which I can see that this is a loop agent. So here, this is a sequential. My writer's room invoked a sequential agent. This sequential agent is having this loop, so that will go to the researchers in writer and all. It's still running. Once it's done, so we will go back in here. So we have the film concept. It will go through all the sequential. It will write through the writer. It will go maximum iteration of 5, and it will give me, it will get me back a storyline. Let it wait. We'll take a loop. We should have set a iteration of 2 for the demo so that it would be done a little bit faster. So this is going in here. Let's go back to our state as well. We can also look at the trace. So here you can see that we have the invocation. So the invocation is having all the systems, and it is executing the content, and it is also having multiple calls in here, and you can see how the each it's a state trace of each call, how it is making. Okay, let it run it out. Meanwhile, we will look into the next task as well. We will go forward. So what we have done so far is that we have created the sequence, and in that we have run the loop agent. Now we want to create a little bit more complex system as well. So in here, what we will do is that we want to create 2 agents. One is a casting agent, because my critic agent says, okay, this is a good. It has done all the research. Researcher has done all the research, and screenwriter has given me a plot, and critic has said, okay, good. I want my parallel agent. I want 2 agents. Want to do a casting. So let it trigger a casting agent, and I want to do a research on my box office result as well. So we want to do. So what are the benefits of having? So till earlier, even though we were running in loop and sequence, we were able to have the conversation history of one after another, right? We were able to do all the information system. But in parallel agent, these two can independently run without knowing or without waiting for the other. So how does it works is that we need to create two new agents. So I have my box office researcher and I have my casting agent as well. Taking too much time to finish this out. And in here, I want my pre-production team. So this is a parallel agent. So I have two sub-agents in parallel. So in here, you can see that what is the new variable. I have an output key. So in order to save, so earlier we discussed we have the state file, and we used some keys to attach the response. In here, I can say my output key and whatever the response of the agent. So for example, this box office researcher agent, whatever the output of this agent, I can directly save the complete system, complete response into the system state. So I can say, okay, use the output key of box office report and save the response of the agent in here. So let me copy this here, and I will come back into the workflow agents.py. I will go and initialize all the systems. So in here, I have two new agents, right? I have my casting agent, I have my box office agent, and this pre-production team is the parallel agent, which will invoke these two agents. Then now I want to update my film concept agent. So I have my film concept agent. Currently, it is running in sequence. Of first, this is a loop agent, so this will do the complete loop. Once it is done, we need to say, okay, before writing the to file, I want my pre-production to run. So I'll copy this complete system. I will run this. I will make sure that my pre-production team executes before my file writer, and then I want to provide a little bit more instruction to as well. So I want my file writer to have a little bit more instruction. So I will come here. So this is my file writer agent. My instruction currently uses these. I would say replace my instructions in here, and you can now see that I'm using my earlier we used attractions and question mark, right? So similar to that, I can say, okay, I have my box office report and my casting report. So this would run independently. This would take the details from the state file, which are run independently, and write into my file writer. So I will save this. I will make sure that my system changes. Yes, good. I will save that. I will come into the agent. I will create a new session. In here, I will say hello. I want to create. So now let's say I want an actress who invented technology for Wi-Fi. Okay, so this is my plot line. Let's see. Let me because I have enabled. I'll create a new session. Say hello. Yes. Say this is my prompt that actors who invented technology for Wi-Fi. It will see it is prompting and append to state. It is triggering a transfer agent. Okay, transfer agent done. It did to Wikipedia. Wikipedia is done. So it will append to the state. Okay, what is my state now? So you can see this is my complete state, right? So now it is in my researcher and it is running in a loop, which will go in here. So you can see this will go into this parallel agent as well. Say, okay, now I have my state file. I have my researcher state file. It's appending Okay, cool. Which is what is my latest state. So I have my plot line. So yes, I have my plot line created. Now it found, okay, my critic is good. Critic says, okay, do the exit. Now it has created the details in the state. I have my costing report. Like I mentioned, my key value has the key of costing report, right? Now it will go to the frequency, sorry, box office report. It's also imported to the state. So I have my box office report and in my state as well. Now what it will do, it should complete or to take all the information and write that into the file. Yes, it is writing into the file, completed. So the movie is called The Secret Frequency. It has created the movie with the name. Let's open the file, go back to the editor. I have the secret frequency. I have the plot line. I have my complete details. I have all the security summary of, I have the details of it. Then I have the costing report and I have the method of the box office as well. Cool. Now I have completed an end-to-end system in this. So let's say I have all the systems. So we have been able to made the complete from a gator from a single input without running any interference. We were able to do a complete loop. We were able to do this loop agent in parallel agent in sequence and do the after the parallel agent in sequence, we were able to write that into a file. Awesome. So once you are done that, congratulations, you have completely successful that you have completely completed the lab. So now we have seen a lot of information, right? So we have been able to make a lot of different systems in which how we are able to. So like I mentioned in the beginning, this is ADK 1.x. So ADK has a newer version which brings a little bit more advanced capability to you. So what are the new major capabilities that the ADK brings into the system? So ADK brings three major capabilities in 2.0. One is that graph powered workflow. So earlier we were able to create workflows, but we were too rigid and we wanted to break into systems and we want to create a lot of agents, parallel agents, sequential agents, and everything. This has been simplified into a method of graph workflows. Then you have the power of creating dynamic workflows, and you also have got a collaborative modes between the operating systems. So how does the graph workflow works? So you create agents as nodes. It can be agents, functions, tools. Then you create edges using the nodes, and then create the workflow by connecting these nodes using the edges. Dynamic workflows provides a little more functionality. You can have a little bit more recursive control conditions loops. You can have a programmatic wait and you can sync and async. You can invoke checkpoints or you can have human in the loop designed automatically. On the collaborative task as well, right? You can have a specified agent or a transfer. You can have single turn or complete autonomous delegation as well. So that brings back to you, Abhi. Wait a moment. I think Abhi is having some network issues. Sorry, I think there was some network issues in meanwhile. If you're able to hear me, let me know. I think that would be all. Uh, Thank you all. Thank you so much for joining us today. It was great pleasure. Feel free to complete the task and let us know if you have any questions.